So hey everyone, so this is the editorial for Div 3, not exactly an editorial, most likely an overview. I'll be summarizing all the problems. So problem A se we'll start. So you're given an integer n on one turn, like on the first turn. Vanya starts and she will increase or decrement the number by 1. If it's divisible by 3 after Vanya's turn, Vanya actually wins, otherwise the other player wins. So this is simply straightforward. So basically if the number is already divisible by 3, so they actually highlighted after. So if the number is already divisible by 3, that doesn't mean that Vanya is winning. So if a number is divisible by 3, Vanya will either make it 2 or 4. So let's just say the number is 3, she will either make it 2 or 4, and then again the second player will again convert it back to 3, like if they play logically. So that way Vanya would never be able to make the number divisible by 3, and 10 moves will pass by and the second player will win. Otherwise, if the number is not divisible by 3, that means it's somewhere in the between. So every 3 number, so divisibility by 3, right? So every 3 number, after every 3 numbers the number is divisible by 3. So either by increasing or decreasing the number, she can get the number to be divisible by 3. So suppose if the number is 5, she can convert it to 6. Like there is always a neighboring number which is divisible by 3, so that way Vanya will win. So not exactly showing the code, but you can just assume. So if n mod 3 0, the second player wins, otherwise the first player wins. Moving on to the problem B. So just read the problem once. It's again a simple problem. This is something I missed. Hmm. So here the thing that we have to, like, so basically if you consider, you know that the number of trucks actually need to be divisible by the number of boxes, or the vice versa. Like, you know the logic, right? So you want to load, suppose there are a total of 6 boxes, you can only get either one truck, 2 trucks, because 6 is divisible by 2, 3 trucks, or 6 trucks. So these are all the factors of 6, right? So to iterate over that number of trucks, you can actually iterate over the number of trucks, because it won't be more than 20 or 30 for any number. Like, that's a fact for factors. So again did the same thing. So the tag is also brute force. So you just find all the factors. One second. Just find all the factors, and once you know the factors, just iterate over the factors and do the brute force. Like, try getting, like, assume you have these many trucks. So if you have these many trucks, then how many boxes will go in one truck? That's exactly equal to k, and then keep on loading them and keep them in some maximum, and do the same thing for all the factors. So again, that way you can get the answer for this. Problem C. Yeah, so if you know Kadane's algorithm, this is very simple for you. So basically you have to apply Kadane's only, but the only thing that you have to consider is you can only apply Kadane on the sub array which has, so suppose you are given an array, right? You are given an array and you actually make a parity array, like you actually make a parity array for this. So how that would look like is, suppose I have, okay, why is this not working? Yes, suppose I have 1 3 5 2 4. So the parity array for this will look like 1 1 1 0 0. So this is basically mod 2 of that array only. So once you have done that, you have the parity array. So you can only apply your Kadane's algorithm on a sub array which is following the logic. So suppose I'm the parity array something like this: 1 0 1 0 1 1 1 1 0 1 0. So if I make the array for this, it would be like 3 4 1 6 1 1 1 3 4 3 8. Okay, so if you convert this array to parity array, that is just do mod 2 of the elements, you will get this array. So if you look at this closely, this is a valid subarray, right? This is a valid subarray, and this is also a valid subarray. So these are valid subarrays, so just select these and apply Kadane on them. That's all you have to do, and you can find, like Kadane is a famous algorithm. So that's what I did basically. So I made the parity array, and then get max is my Kadane get max. This is giving me, this is exactly the same Kadane's algorithm. And sorry, I have to zoom this, huh? So you can just get the maximum of all of them for all the Kadane operations. You just need the I and j, like at which particular range do you want to apply Kadanes. So like I just like I ran a loop for all the alternating parity elements, and once you have them, just get the maximum answer. Musical notes is also a simple problem, but I messed this up because I was using multiset. Then I moved to map. So if you see, my most of the time went on problem D only, but silly mistake. So this problem is also simple. So what exactly they are asking is, so let's just consider, and yeah, I will consider an example something like this. So suppose you have 1 second. So suppose you have something like 2 and 4. So this is so this is given in the array, but the actually it is 2 square and 2 raised to 4. So when are these two pairs valid pairs, or whatever they call it? If 2 square raised to 2 raised to 4 is actually equals to 2 4 raised to 2 square, correct? That basically means, just if you just take log 2 both sides, if you just take a log 2 both sides, this will actually come up to 2 into 2 raised to 4 should be actually equals to sorry, mm, this was actually come up to 4 into 2 square. Now if you just take it, yeah, either other, it will be 2 4 and 2 square by 2 4. Now just look at this closely, this part would always be like the initial numbers were 2 comma 4, right? So this part, so we are just considering this is a valid pair, like we are trying to prove that this is a valid pair. So every time the RHS would end up like something like this for any pair. It would be like a by b is equals to 2 raised to a by 2 raised to b. For them to be equal, you have to, like, the eventual equation would be something like this, right? So once you have this, then, so how do we make this thing equal? So this thing 2 raised to square by 2 raised to 4, this would always come up to be like, this would always turn out to be 1 by 2 raised to b minus a. I'm assuming, like, we are also assuming b is greater than a, that, so that thing will sort the array and we'll take care of that. And this is actually the proof for any a comma b wala pair, and b is greater than a. So eventual equation would be something like this, that we saw, like if we do log to both sides, we will get this. So b is greater than a by b, 2a by b, 1 by 2 b minus a. So what they are saying is a by b should be equal to 1 by 2 raised to b minus a. This is the condition that is to be met for your pair to be valid. You got this, right? So how do you do this? So for this to exist, for this thing to be valid, your uh, b, like, if I just, for this to be valid, what should be the, like what should be the requirement? Like, now we'll make this more generic. For this to be valid, like a by b is equals to 1 by 2 in, so like 1 by 2 raised to b, sorry, b minus a, your b should be equal to a into 2 raised to b minus a, obviously, right? Yeah, so that is basically it. Like, find a b such that 2 raised to the difference gives you a. Now how will you do that? So what I did is, I actually first sorted my array. Then suppose I am at a 2, then I am iterating over all the possible scenarios. Like, so suppose I am at 3, like, you will understand the code. So suppose I am at 3, and over here I have all the elements which are greater than me. So I will first search for 3 into 2 raised to 1, then I will second search for 3 2 square, 3 into 2 cube. I think there's a better solution for this, but anyways. So 3 into 2 raised to 1, 2 square, 2 cube, 2 4. Now once I have this, so I know that, so in this whole iteration, I know my a is 3, and these are all the possible values of b. So a is 3, and let's just say our b is 3 into 2 raised to 1. So that means obviously my a by b is going to give me 1 by 2, correct? But then you also have to check इज दिस 1/2, इज दिस, ये जो 2 है, this 2 raised to 1, is this equal to b minus a? Is this equal to 2 raised to that b minus a? You got this right? Like this thing is what is going to remain after you cut a by b. This thing should also be equal to b minus a. Like just look at this once, because if you select a as 3 and b as 3 into 2 raised to 1, then a by b is going to give you this thing, is like this thing will be left out 2 raised to 1, and this thing 2 raised to 1 should actually be equal to this part 2 raised to b minus a. So इसका जो ये वाला power है, this should be equal to b minus a, not that whole thing. ये forget it. This difference, that 2 raised to 1, ये वाला चीज़ should be equal to b minus a, and that you can easily brute force, क्योंकि this thing, how far will you go? This you will go max to max 3 into something, because then you will eventually cross 2e9 to like 1e9 9, right? Like very soon you will cross, like in 2 raised to 26 or 27 you will cross 1e9. So you can just iterate over that. Now like ज़्यादा ही हो गया थोड़ा. If I just show you the code once. Bad net. हाँ. So initially I kept a track of the elements. I sorted my array. Then as soon as I am entering that element, I will remove, like I'll be removing that from my frequency wala map. Then I have the current element as ARI. Then I'm initializing my multiplier. And what is my multiplier? In this case, it is this. Ye. I am initially starting with 2 raised to 0, because you also have to take care of the same elements. This is my multiplier. Then how I am taking care of that multiplier? Then I'm doing, so basically I'm going till 32, like you can configure this, but I'm breaking as soon as I cross my current element as 1e9. ARRI 1 left shift J, then I get the count of that element जो मेरे को चाहिए था after the multiplier thing into 2. I'm asking if there is a count and the difference, absolute difference of current element minus ARRI is equal to the multiplier. And what was the multiplier? As I said, the difference should be equal to the multiplier. And if I find such an element, I'll be simply adding its count. Like just rewind and look at the explanation once again, you'll understand. Like you can just also do the maths, or like maths yourself, and you'll understand what exactly needs to be done. ठीक है. Then the E and F were more easy than D, to be honest. This is again like a CB level problem, but so again a simple problem. First element निकालो, पीछे डालो, keep. So basically any element that is फर्स्ट पोजीशन में वो पीछे जाएगा और वो एक्चुअल में अपने सॉर्टेड पोजीशन में चला जाएगा. बट द थिंग इज़ इफ़ दिस वन, लाइक अगर कोई मिनिमम एलिमेंट एक बार फर्स्ट पोजीशन में आ गया, इफ़ एनी मिनिमम पोजीशन लाइक द लीस्ट नंबर वो कोई फर्स्ट पोजीशन में आ गया, तो देन यू कैनॉट डू एनीथिंग. देन वो फर्स्ट पोजीशन में आता रहेगा, इट विल कीप कमिंग इन द फर्स्ट प्लेस. यू कैनॉट डू एनीथिंग एंड वो सेम चीज़ लूप होती रहेगी. तो द कैच इज़, एक बार क्योंकि वन से पहले जो भी है ना, एक बार ये वाला ये नहीं, ये तो अलग ही था, ये रन कर लेना या फिर ये भी रन कर लेना. सो वन से पहले जो भी है ना, वो वन के पीछे जाके अपने सही पोजीशन में बैठ जाएगा. जस्ट डू द ड्राई रन वंस. बट वन के बाद जो है, और उनमें से अगर कोई अनसॉर्टेड है, जैसे फॉर एग्जांपल दिस 6 and 4, ये अनसॉर्टेड है अगर, यू कैनॉट डू एनीथिंग अबाउट इट, क्योंकि उसके पहले वन है और वन 6 और 4 के पहले है, तो वो कभी 6 और 4 को चांस ही नहीं देगा सॉर्ट होने का. सो द सोल्यूशन इज सिंपल. जो मिनिमम एलिमेंट है उसके बाद, मतलब ये वाला पार्ट जो अरे का है, दैट शुड बी ऑलरेडी सॉर्टेड, एंड इसके पहले जितने भी एलिमेंट्स है, दैट इज़ योर नंबर ऑफ मूव्स दैट यू हैव टू डू, क्योंकि उन्हें सॉर्ट करना ही पड़ेगा, क्योंकि फर्स्ट नंबर हमें आगे लेकर ही आना है. सो अगेन इफ़ यू लुक एट द कोड, ये वाला पार्ट, I find the index of the minimum element, then I check उस minimum element के आगे से सब कुछ sorted है ना. If it's not sorted, it's -1. otherwise वो minimum number जिस position में है ना, that is my answer, because उससे पहले मुझे चीज़ें sort करनी पड़ेगी. ये this was a good question, मतलब not good question, but ठीक है. just read the problem once. थोड़ा complicated problem है, but you'll understand, like इसका solution is very simple than the problem, but just understand the problem once. So how I design the tree, like I am directly getting to the solution because it's very simple. how I design the tree is, what I did is, this is my like no matter the number of nodes, this is my tree structure. Simple. How is this working? So suppose my d का value is 2, तो ऑलरेडी है, ये एक लीव है, ये एक लीव है, उनके बीच का डिस्टेंस का वैल्यू 2, सिंपल राइट. डी का वैल्यू कुछ भी दे दो मेरे को, अभी तुम लाइक गिव द वैल्यू ऑफ डी एज 3, आई विल रिमूव दिस थिंग, आई विल रिमूव दिस थिंग एंड आई विल पुट इट ओवर हियर. ये लो 1 2 3. सिमिलरली 4 चाहिए, रिमूव दिस, कीप इट ओवर हियर, 1 2 3 4. वापस 3 चाहिए, रिमूव इट फ्रॉम हियर, कीप इट ओवर हियर. सो यू आर जस्ट एक ही नोड के साथ तुम खेल रहे हो और उसको ट ट ट जहाँ लगाने लगाते रहो, इट विल कीप गिविंग यू द करेक्ट आंसर. समझा राइट? लाइक प्रॉब्लम उन्होंने बहुत ट्राई किया कॉम्प्लिकेट करने का, बट if you read the problem very closely, they gave you the right to design the graph and the right to make like तुम्हारी operations तुम्हारे graph, बस ये d meet होना चाहिए. अभी तुम कोई भी d दे दो, यहाँ से बन जाएगा, इसको हटाओ वहाँ डाल दो, ये कितना बन गया, 1 2 3 4 4. दिस इज़ 4 डिस्टेंस. यू वांट 5, टेक दिस, कीप इट ओवर हियर. दिस इज़ 1 2 3 4 5, कीप दिस यहाँ पे 6. सॉरी 6 के ऊपर कभी जाएगा नहीं. यू अगेन वांट अ 2, इसको वापस यहाँ से हटाओ, वापस यहाँ लगा दो. सो तुम एक ही नोड के साथ खेल रहे हो. मैंने कुछ मतलब इफ़ यू लुक एट द कोड, इट्स अगेन वेरी सिंपल. सो बेसिकली आई डिज़ाइन समथिंग लाइक दिस 1 2. सो सपोज मेरे को n6 दे दिया, सो दिस इज माई 1 2 3 4 5 एंड 6. तो n-1 और n-2 को मैंने n और n-1 को मैंने n से जोड़ दिया, एंड उससे पहले सब कुछ टिल 1. दिस इज़ माई डिज़ाइन. एंड फिर मैं बस ट्रैक कर रहा हूँ कि अच्छा तुम्हें 2 चाहिए, तो यहाँ पे मेरा 2 था, 3 के लिए कितना चाहिए और 1, तो इसको एक और ऊपर ले जाओ. अभी मैं करेंटली कहाँ हूँ, दैट आई एम कीपिंग ट्रैक. फिर वापस मुझे वहाँ से मूव करना है, 4 से मैं वापस कैलकुलेट करूँगा मुझे कितना ऊपर जाना है, 1 पे जाना है, देन ठीक है डायरेक्ट 1 पे जंप किया. दैट इज़ हाउ आई डिज़ाइन. इसका कोड का यू कैन हैव योर ओन वे, बट लाइक ये तुम्हें समझेगा नहीं, इट्स सिंपल. मैंने n इज इक्वल्स टू 3 थोड़ा अलग से हैंडल किया, वो कोड के साथ जा नहीं रहा था. एंड देन j इज इक्वल्स टू 2 शायद जाएगा, ठीक है. एनीवेज डीबग एन, आई वही जो मैंने बोला, मैंने लास्ट n-2 को अलग से जोड़ा है. लास्ट कनेक्टेड मैंने ध्यान रखा है कौन सा. सो बेसिकली दिस इज़ माई लास्ट कनेक्टेड, ये वाला पार्ट, दिस इज़ माई लास्ट कनेक्टेड. एंड वन फाउंड डन. अगर मेरा डिस्टेंस ऑलरेडी वही है, क्योंकि मैं करंट डिस्टेंस भी हमेशा अपडेट कर रहा हूँ, क्योंकि उन्होंने बोला है कि आंसर ऑलवेज एग्जिस्ट, आई एम ऑलवेज अपडेटिंग द करंट डिस्टेंस. एंड देन मैं उसी चीज़ को, सो दिस इज़ माई फार्मूला, मैं n-2 से हमेशा कैलकुलेट कर रहा हूँ कि मुझे कितना ऊपर जाना है, एंड मैं अपने वो वाले नोड को वहाँ से लाइक आई एम मूविंग दैट. सो दिस आई सॉल्व एट द एंड मोमेंट. So if you like, I don't know if any of my solutions would fail. If they fail, I will obviously remove the video. But this is the solution. कुछ doubt है तो feel free to ask me in the comments. Bye bye.